Hey, welcome back to Detection at Scale. This is season 3. And this season, we've really been focused on the intersection of generative AI and security operations. And today, we have Slava Klimovs from CoreWeave. Slava, I'm super, super excited to get your perspective on this topic and really excited to have this conversation. So welcome.
Yeah, Jack, thanks very much for inviting me. I'm very excited to be here and very honored. Thanks for having me.
Yeah, so let's jump in. So, how did you get here? What were the really important moments of your security journey to date?
Well, I've been at CoreWeave for about, 10 months at this point. I am responsible for all aspects of security, threat modeling, detection, prevention, response, compliance. My scope of work is the same as CISOs, but I'm an individual contributor and I report to one. Before that, I spent 18 months at Snapchat in basically the same kind of role. And before that, 13 years at Google in a variety of kind of functional roles, but overall, focus on infrastructure security, identity and access management, zero trust, production perimeter, and so on. Before that, Opera Software, my background is basically build-oriented security, although now it kind of involves, every kind of security.
Let's talk a little about CoreWeave. So CoreWeave is a pretty exciting company in the world of AI right now, just given the massive need for compute and the services you all provide on inference and training. So, what was it like to sort of join with fresh eyes and talk to us a little about that 0 to 1 journey of bootstrapping security and kind of getting things going?
Yeah, great question. So CoreWeave was a very interesting journey, certainly due to, relative size and maturity of kind of my previous gigs, was certainly least mature and least in size when it comes to security team, but not due to people not trying or so. It just fundamentally kind of was there. And it was through 0 to 1 journey. We had to walk through setting up some of the fundamentals, and the existing team, that was there before us, did a heroic job corralling and making sure that things can work as intended. But we nevertheless had to set up some of the things from scratch. And one of the things I think that's interesting to talk about is kind of priority when it comes to, new CISO coming to a new place. What is the most important thing to do? And I've developed over the years pretty strong opinion that the most important thing to do in virtually, there probably will be exceptions and nuance, right? And so on. But, a big picture is the right thing to do is security observability. So, are we getting all the data? And there's tons of technical work that is involved in this. So that's super important. And then there is the scope more creative, but essentially when it comes to technical work, let's say log coverage, there's, kind of you either have it or you don't. When it comes to what you do next is a little bit, there's no single right answer. Are you going by TTPs? Are you going by environment coverage, surface coverage, or, you're focused on the insiders? Maybe that's the right move. But we basically had to realize that the existing platform isn't able to meet our requirements, and had to kick off a large process of rebuilding capabilities from scratch, which also leads together with the detection platform. You have SOAR, and you have a tip, threat intel platform that is now subject to change or subject to being acquired, and so on. So kind of a detection first approach, and even if your data isn't perfectly parsed, forensics on it is extraordinarily important. Like, even if we can't tell us something bad is happening, can we tell that something bad has happened, and specifically when it did? Well, can we tell what exactly went down, kind of in form of forensic analysis versus alerting or so? And it's a couple of interesting bits there, like levels of abstraction. There's obviously the lowest. There's kind of the lowest level, which is single log line, and then lots of events consist of many. And if you think about the layering of those events and so on, and also the naming of those things, can be subject to interpretation, but there is something above the event, and then there is something maybe above that, and so on. And how do you define the layering and abstraction layers is important. And going back to sort of what's important, the other bit that became, very important for us very quickly is making sure that all work that is done, let's say in the realm of security, now compliance is driven by customer requirements. So this is going to be a little bit different. But in the realm of security, every single thing we do is driven by a concrete threat model. Like, kind of the failure mode that I've seen in the past is that security teams work a little bit sometimes scoping in abstract, right? So there's a it's a particular system or a process or a product that they kind of like to work on, and they continue to do that without, taking a step back. And it's like, is this kind of the most important thing we are working on? It's okay if I do like, some small amount of hot takes, right? Like a hot take is probably 40 to 50% of security work that is being done is not being done in relation to concrete threat model. Like it's done for whatever, some other reason, so to speak. Even in cases where it is probably, explanation is very, very hard to obtain. And it's not the fault of the people who are working on it, but just, people don't spend time reasoning about what they're actually working on. And in my opinion, in many cases, if they were to, and be open to interpretation of the results of saying, like, we're trying to do this and this, and the threat model is this, and you start breaking it apart. And in many cases, people realize that actually what's being done isn't actually going to address the threat model. And I think, if there was, and that is kind of like a question of technical leadership, in my opinion, at least, I think if there was more of that, the security teams would have been essentially more successful at the core part of the work. So yeah, detection platform for making sure we're working against the concrete threat model, no matter the area of work. Again, compliance being not part of this because it's driven by customer requirements. And, obviously the team is growing, organization is growing, you do have resources to work on prevention. I guess really quick sort of sidebar, why detection is significantly less intrusive than prevention. It's just the objective reality. Like, even it is work and influence to get the teams to log. And sometimes you have to go vertical. For example, yes, the system is logging, but the contents or the place where the log statements are in the code of this third-party system isn't actually useful. Like, it's not logging key state transitions. It's not logging mutations, and so on and so forth. That means kind of going vertical, horizontal being kind of log coverage across systems, and then vertical being, within the particular system. Are we getting useful stuff? Are we getting enough stuff? Is it too much, actually? That's another problem. Cost mainly, but, and so on. That is significantly less intrusive than saying, like, well, we're going to, roll out, unphishable second factor. We have that at CoreWeave. But, say, again, phishable second factor or mandatory, transport encryption on a WAN, or, a crypto scheme of this particular nature, or we're going to change the way secrets are managed for the better. Like, all of those things are tremendously intrusive. And in a fast moving environment, chances are a particular system is in maintenance mode. Like, who is there to change how the system does transport level encryption if it's in maintenance mode? If developers are doing something else that is very business critical, and it's kind of very important. But prevention wise, interesting project kind of to briefly mention is the project that we are doing for host integrity. So production machine integrity. And of course, that means software in this case. But the interesting bit is that software starts from very early on. So we power the host, and already a software firmware, you could call it firmware, is already executing. We're really far away from talking about UEFI and secure and boot. A variety of pieces of software is already executing. How do you know that this is the software that was intended to be here? And there are ways, SPDM attestation, Calipra, and all that kind of good stuff. That is what we're going to do. It's kind of in the process of rolling that out. You transition to secure boot, and that's fairly self-explanatory, I think, for most people. And then what happens later? Like, we have, so kernel is okay. We know what kernel is and how it was booted. We know about the early user space. We know about the entirety of UKI image. But what about the actual user space? Once eventually kind of gets created one way or the other, how do we know that is integral? And I think unique aspect to us is we decided to see this whole process in one single model. And we decided to generalize between concepts here. So we kind of have things that are measuring next stage typically. There's a bunch in firmware level, UEFI, and secure boot is that way. And then onwards to kind of user space. And then, we have to have some kind of enforcement mechanism. So we see it as a pluggable situation. Like, it's network enforcing. Like, basically, it's not exactly like this, but it's the quarantine VLAN. Like, are we good with this host? What if we're not good? Where does it go? How do we troubleshoot this, right? So, and then how do you know what good looks like? So yes, the particular chip, a root of trust on a particular chip says, I've booted this hash of firmware, and here's my signature over it. That way you know that nothing has been tampered with in between, me and your system. But is that the good hack? How do you know that? And there's ways to deal with that up on the vendor side in the firmware space, and then we are the providers of the kernel for secure boot, and the user space comes from its own. So again, we're talking about conceptually a mechanism of ingestion of how the good looks like. This kind of has to be built, and we're doing that. Well, I think that's paints some kind of picture. Obviously, this is just my personal view as to what's sort of exciting and it's top of mind. But there's tons of work going on in a big team of very, very talented people, and just because I'm not talking about it doesn't mean it's not important.
You guys seem pretty busy.
Thank you.
That's awesome. No, I love it. I think there's a lot of really interesting bits that you're working on. One of the things I wanted to double click into is this quote you said. You said 40 to 50% of security work is not done in relation to a concrete threat model. And, I think it's, as an aside, I think it's very easy for us to get distracted on our day-to-day on what's most important in security, just because we're pulled in so many different directions. So I guess my question is, why do you think 40 to 50% is not actually done working towards a threat model, and it's just seemingly random, or might just be something that popped up?
Just to be clear, the number is seemingly random. It certainly is a large number. It's not insignificant number. Why is this? Because it tends to be easier. So, first of all, there is an obvious question of determining the threat model. Now, let's talk about sort of, elephant in the room, right? Like tons of security teams, organizations, subparts of organization work without one. Like there's no artifact to ask for, and tons do have it and so on, but there's simply no threat. No one cared at any point to kind of write down the threat model. Second is it's not detailed enough. It hasn't been thought through is kind of another big problem. And the other bit, let's say, and this is already, it's kind of like this levels, right? Simply no threat model, actually not high quality enough. Like if you say in your threat model, you say you have some kind of web product, let's say, right? And say you're worried about session hijacking, common, right? Like problem on the web, so to speak, relatively common. What does it mean to your product or to primary IDP of the user? Which ones are you worried about? Then there's tons of other variables that go into it and so on. So you can't just say that. It needs to be more detailed than that. But of course, you can't also spend paragraphs and paragraphs on the session hijacking, because now your threat model is 60 pages. No one is ever reading it. It needs to be useful to the point where a technical, but not necessarily directly an information security kind of person can comprehend what are we worried about, from whom. Like big part of threat model is enumerating actors conceptually, of course. So who are we worried about, and why are we worried about this, and why are we worried about that, and so on. So like again, no threat model, it's not high quality. And then finally, there is threat model and it is high quality. What will tend to happen is the problem that it as a result boils up to be like, okay, this is the most important problem, is very difficult. It will be a very difficult problem. It will be just fundamentally a lot harder. It'll be a difference between a stroll in the park to deploy some control that realistically no one needs or doesn't really solve anything, and like running uphill, both organizationally, often technically, sometimes in many cases, and it really should be kind of like a staff level and above. It will require inventing things. Like especially when it comes to scale and the places that run at scale, it will require no one has solved this before. So that is pretty difficult. So there is kind of difficulty in terms of a rollout and not breaking production and being within the envelope of what production is willing to spend resource-wise on a particular control and so on. And there's a difficulty in form of just algorithmic / systematic difficulty. No one has solved like this problem with these exact constraints before. And as a result, frankly, I assume within hot takes budget. So frequently people will choose something that leads to a promotion and or, recognition, maybe actually within the industry, right? Maybe the actual top of the threat model is not something that, in the particular example, right? It's not something that's going to lead you to be like a conference topic. or a paper or something like this. It will be like grind and difficult in many ways, but all you're going to get to at the end is actually the state that everybody perceives you're already in, something like this, right? So as a result, that's not the choice that's being made. The choice, and it's not kind of an explicit choice, like, oh, we're going to ignore the top of threat model. It's just systematic. This system is not helping to kind of push towards doing the right thing threat model wise versus easy thing threat model wise. Now, this is to say, there's tons of teams and programs that do operate off a threat model. And if you take a very big corporation, you cannot have single one. You have to develop, threat model per some kind of unit or sometimes per product if you talk about very big place. And that is done, in many cases and so on. But I also know of many, many things that have no substantiation behind them at the end of the day. I'm going to talk about that. But
And I think the idea of like working on something flashy over something that's high impact is kind of a unique Silicon Valley problem to an extent. That's just my own opinion about it. Like, since I'm not from here, I guess I am now. I've been out here for 13 years, and that's longer than anywhere I've ever lived. But I just think that trend of like, let's go build and invent something to show our impact, like that just seemed like a Silicon Valley trend. So just want to say that. And then, yeah, I'll agree with you. People don't tend to write their threat models out. I don't really know if there's a lot of good guidance and examples out there, to be honest. Like, I had limited exposure to that, and we obviously wrote down what was important, but it wasn't super standardized. So there's probably an opportunity to do a better job there.
I think, if just really quickly, I don't think form of a threat model even just people tend to pay attention to this, like, oh, are we using, this framework or using this other framework? I personally don't think it matters at all. I think the content, it needs to express certain things as long as it contains the actors, the motivation, and why this is applicable to here, and also relative priority as a result. There's some nuance to this, but fundamentally, like, it's a good one. Is it written, that threat modeling framework or the other? I think it's not, not something that is important. I think I completely agree. You're completely right. It is a Silicon Valley problem, but even when we are not in Silicon Valley, as in like, it was generally in a West Coast, I suppose, kind of technological sphere of influence. We live in it, right? So people chase promotions, right? Chase titles. So it became, kind of unbearable in some sense. People with 5 years of experience saying that they're staff level engineer and all that stuff, right? So not people's fault. It's, it's the environment we're in.
Yeah, fair enough. Okay, so I want to pick your brain on something. So obviously CoreWeave is an AI company, and the nature of what you provide is very technical, very low level. How are you thinking about agents in the security team? How are you thinking about agents that augment your security team? Are you even there yet in terms of thinking about this, or is it more of just more on the hardware, the firmware level? Like, where's your thinking?
Well, first of all, I'm very excited. I cannot wait for our agentic overlords. We are we certainly have a lot of very low level technical problems, but we're also in a position to think about that. And I'm very optimistic, certainly long term, as to where this leads. I think I'll give you, rather than talking about this theoretically, I'll give you a specific example and it's not going to be agentic. It's still going to be the older school LLM, and so on. But I think it maybe illustrates the optimism that I have, which is, so design docs, right? How do you write them? You write them short, you write them long, do you write them at all? Does it even matter? And the discussion I had recently, I think and it's going to be extreme in a sense, but like, you have to have a design doc and you need to remove everything from it that could have been written by LLM. That will probably make your design doc go very short, but it's going to contain that exact essence that an LLM could not have made a decision on. Because fundamentally, it will just make a decision whichever way you guide it. But there are local constraints, local environment, local talent, local budgets, and so on and so forth that aren't going to be kind of known or correctly expressed. And sometimes, frankly, there's just a gut feel. There is sort of, senior engineering gut feel about, okay, this is the way to do this. And what design doc that has every fluff possible from it removed forces us to do is it forces us to expose the gut feel, in other words, intuition to kind of the audience and so on. And I think that's, freeing people from writing the opuses and upon opuses of design, is just a fundamental improvement to life and to time consumption by everyone else, readers mainly. The docs are for readers, right? They're not for writers. And then there's some with this for writers, right? But I don't know with this for readers. Yeah, it's not an agentic AI example. We don't have any agentic AI security just yet. We do have some in enterprise, like helpful agents, a particular vendor, right? That do certain things. And I'm very excited for the future when it comes to things like this. I do think there is something that this does to security, which is that it simply makes it much more unforgivable. So, while in the past, certain things could have been helped with by manual review, let's say, most places are moving away from that, rightfully so, or, it's okay if the access, let's say access for, and this is where the AUC comes from, but it's okay if certain access is over provision because, nothing bad is going to happen. Well, what's going to happen with agents operating alongside us in an enterprise, especially in production, is that all those issues are simply going to come out of the woodwork and it's going to bite us, like right there, right? So the level of tolerance to things like over provisioned access or very important, right, in the agentic space, like bearer tokens. So, I like to say that there's only two problems in security in general: bearer tokens and inventory. And everything else just boils down to those things, right? So bearer tokens, right? Like, so we always have this tolerance to some amount of them. That's going to go away because you don't want your agent to hand over the relevant bearer token to like some other agent, let's say, that may be lesser privileged one or something like that. And we need to have unexportable identity fundamentally. And agents is an interesting combination of being treated in some sense like humans, but in many ways it's systems, right? And there's whole trend right now in the industry about non-human identities and so on. I think it behooves on us to try to align it with some of the concepts we know. Yes, it's not a human and not a service per se, but what are some of the things we know from human access and service access that we can use for agents and utilize? And the funny thing is, very few are brand new. They're not really applied. Things like just-in-time access, delegatable, like credentials that are delegatable in scope. And the concept is like old, age old, really, right? Was it ever properly implemented? Not really. We're just waiting for someone to kind of implement that, I say. Yeah. So, sorry, long-winded, but agents.
Going back to the design docs are for what? Internal projects, internal applications, things like that?
Yes. Or control or a compliance, a way to meet compliance requirements. Anything. Right? It's a key kind of engineering artifact.
I like the idea. So you're effectively advocating not for using LLMs to...
Well, if it helps, right? If, for example, if it helps to... This can be done manually, but I think it requires a lot of kind of skill and maturity on the level of writer. Because, once people write something, they kind of get really attached to it and so on. The key is to get really disassociated with this and be like, oh yeah, delete all my stuff. I don't care. Like, I love when people delete my code. It's my favorite. If someone is mature and capable enough recognizing that this sentence or this paragraph actually doesn't say anything new and it could have been written by LLM, they can do it manually. But also, what if it's run through an LLM? It's like, okay, remove. Like, we don't generate. We want to use generative AI to remove extraneous stuff from it. I think this is like not a good idea.
Yeah, I agree. I've been thinking a lot more about which domains LLMs really shine in, because it's really a massive behavioral change that we've been going through for the last few years here, where we know that LLMs just have such an insanely deep and wide amount of embedded data. But then also there's just things that it's naturally really bad at. So how do you think about applying the strengths of an LLM in the realm of something like security?
I think the answer is nuanced and saying in the realm of security. I think there are places of security where regardless of how you got there, you need, a strongly deterministic, when it comes to, especially compliance regulated situations, right? You cannot have the situation like you're going to have, God forbid, you're going to have your CISO in front of Congress. Like, why did someone get access to blah? Well, LLM said so. Now, explainability and so on is getting improvement, but fundamentally, the way it's probably going to end up working anyway is, change the configuration with the help, and then still there's kind of accountability on a person, sending it, and the person kind of reviewing the PR, and so on. Autonomous, positive access control. I mean, I'm still kind of not there. Maybe someone can demonstrate a system with, empirical data, so to speak, but fundamentally, right? It's on the flip side, but again, even there, what can we do to translate human intent into configuration that we then manage through via regular source control and so on? That sounds great. I think people should use as much as they can get away with in an environment. There's some responsibility and accountability. When a developer sends a PR to their team and they use, AI, that's fantastic. I think it's very, very good. However, the accountability is essentially on the developer. Like, it needs to be that they are comfortable. Did they read it? Maybe they're so comfortable they don't need to read it. But at the end of the day, accountability is kind of with the person sending the PR. But on the other hand, this is, or I went for authorization kind of right away. Obviously, authentication, like you kind of come to Okta and it logs you in once in a while because, it decided like no second factor, no password, just kind of LLM decided that you are okay to log in this scenario. Like no one is going to be okay with that realistically. However, there are other areas where I think it's paramount. And I know there are companies that do that, but for example, customer questionnaires is just, again, a ripe. It's all the same information all the time. There's and I know that there are companies that do that already, right? And so on, but all the information is always there. Nothing changed. Like in the week since the last one till this one, nothing new was deployed. We cannot deploy new fundamental control or change something fundamental about infrastructure in the week. So it's all the same information, just asked in a little different way. Like, I think that's where that, it can be used. Detection of space. We are building our detection platform with kind of AI first in mind. So it's both in terms of just help on analysis, help on detection writing, and again, remember that abstraction layers, kind of important, determining abstraction layers and investigations as well. So also kind of AI assisted from the get-go. And it is kind of my mandate that it is AI first detection platform. Do I think that there is the next obvious concern would be something like, jobs risk, so to speak? Yeah, I think there is some in a sense, but what this does is it removes the concept of analysts and SOC, so to speak. It just all becomes engineering. And you know more about this than I do, but detection is a data management platform, the data management problem, fundamentally. And the other bit I'll say is detection is sort of non-deterministic from the beginning. Like if you've seen large enough infrastructure, you know that X% of the nodes is just not logging at any particular point. They're like host. They're not hacked. They're just, it's a normal production way of production life cycle is that the X% is simply not gonna be there at a time. So very ripe for widespread use. Again, I think people should use it a lot. Forensics, I've seen some things that are pretty crazy for forensic wise with a lens, like fully autonomous forensic on a pretty complex kind of incidents and so on. Any help we can get during crisis like this, I think it's very good.
Yeah, it seems like a lot of these areas, they span different capabilities, right?
Yeah.
So like the customer questionnaire really is just kind of semantically understanding what is this company asking for, and then like what is our actual state of the world and how do we map it, right?
Yep.
On investigation, it's really interesting. What's been the experience there? I mean, how deep have you all gone into the investigation space with AI? I'm curious on learnings. And
we've seen some extremely exciting demos. We have our MVP running in production, but the goal is at this stage is at platform level. It's like, where's the data? How is it indexed? What's the disaster recovery story between the coasts and all that stuff? And we are about to enter, more high level kind of conversation, and we are in tight contact with the vendor about that and so on. So, I'm excited to see what is to come.
Yeah, it's very promising and things are changing so rapidly there. The learnings I've had recently really just come down to kind of first principles with LLMs, which is patterns, right? At the end of the day, LLMs are extremely sophisticated pattern matchers.
Yes.
And that's a good and bad thing, right? It's a good thing when you're working on things that are fairly predictable, fairly well understood. It's a bad thing when it's novel and it is very confident in its answer. So yeah, it's funny. I've gone through like such a crazy wave of like,
New technology acceptance, first there is the
yeah,
excitement, and then there is a trial of disillusionment, and then there is stability kind of at the end.
yeah. Also, I'm thinking of the Dunning-Kruger effect where it's like it's mapping like how much you know about something, and it's like insane excitement in the beginning, and then like trough of like sadness right after,
Yeah.
and then you're like getting more enlightened. I'm like somewhere on the getting more enlightened part, I think, on the beginning of it. But I'm with you. I mean, I think that we should be designing with an AI first mindset, especially in things like code gen. I think you listing detection engineering as a use case makes a ton of sense. It's very well proven. There's just so much code out there. It's actually one of the perfect use cases for LLMs in a lot of ways.
But not that anybody argue, especially not with you, right, on this topic. But there are places where detection isn't as code, so they do exist. And this is example of what I was talking about, which is the age of AI is making these old gaps not palatable. You cannot use LLMs to generate your detections from data because your detections aren't in code. Like, you could, but it would be like unmanageable and not end up well. So like this source control for your stuff becomes not negotiable. And in detection, also obviously the case for kind of code and a product and so on. So I know, it is not news to you or your product, but there are places that do click ops and all kinds of, stuff like this, right? So this is example where the previous tolerable state of subpar, but it kind of works for us, isn't going to work anymore. Now it's not negotiable. Now it needs to be some kind of, and maybe there is someone who is further ahead on the enlightenment curve, and they will say, well, just let it directly fling against an API and so on. But the question is then, like, what happens when it goes wrong? What happens when someone does need to kind of get in and start troubleshooting, or the system is down and we need to make an emergency change? Like the agent is, is taking a break today, and we need to make a change ourselves, right? So now we have a problem, right? Now we have to unwind and so on. And I think this is just the death by a thousand cuts situation is just going to be exposed more and more by the age of AI. The small problems in your infrastructure where it wasn't actually built right from the beginning is just going to shine through much more actively as a result.
I think this is a good segue into talking about the AIUC one. So I saw on your LinkedIn you had contributed to the security part of that standard. Can you just explain what this is?
I think it is connected to, but first of all, I mean, there's this kind of the business model there, of course, right? There's certain company that I get introduced through kind of A16Z folks, and they are working on insurance, and I think this is pretty cool, fundamentally. But they're working on insurance for AI agents, right? So like, we will insure you from troubles. There is kind of in information security, we tend to be on prevent, detect risk, and so on. But there's transfer risk that does exist, and cyber insurance does exist. I don't know why, but they're doing that. But it's not from purely security perspective. It's from all kinds of issues that can sort of occur with an agent. But then as an underwriter, how do they know that the particular one is good? And that's where this problem comes in, right? How do you know that the way, the software provenance, because at the end of the day, AI agent is a software. It does use a LLM, internally, sort of abstracted from its interactions with the world and so on. But what's the provenance of that model? What's the provenance of weights and biases there? What's the provenance of the code? What are the properties of the environment it's running it? Because can it escape it, for example, something like this, right? How are their agents? How are agents' credentials look like? Are they bound to the environment? Are they exportable? And and so on. And if you manage to answer tons of those questions, in affirmative, towards the intended result, it is kind of obvious that your risk will be lower. As a result, I contribute to the standard, which is open, but as a result, insurability of said deployment, right, kind of really goes up, right? That's the interesting part, and that's kind of what attracted me to this, which is this was a way to, in small part, deliver industry impact, and just happy to was invited to this.
Yeah, it looks really interesting. So the website's aiuc-1.com for folks to check it out. It looks just like a really great standard for agents across reliability, safety, security, etc. And it looks like a really nice set of standards to compare your implementations to. So if you're building agents, I would highly recommend checking this out. Awesome. So Slava, I'd love to end the episode with 3 pieces of advice. So, what can we take away from implementing security programs in the age of AI, and specifically around detection and response? So what have you learned there?
Great way to end it, but I think, going in kind of reverse chronological order, there will be no more, the level of tolerance for technical depth and for gaps will be lower going forward. So age of AI brings us to the need to do very good engineering on, are you using a vendor? I really like your product, or are you using something that you deployed on your own cloud, or you're using, whatever the option is, the age of ability to do bad engineering is waning. We are, past the age of ability to get away with simple things. The other bit is that a consequence of that is that we are strongly in the age of detection engineering. And I think that to me really means end-to-end ownership. So no longer there is kind of like tier 1, tier 2, tier whatever, but we really need to focus on maybe verticals instead of sort of horizontals within the team, i.e., this group handles kind of, let's say, enterprise for the sake of argument, and they handle everything end to end, from writing detections to managing them to tuning them. Obviously there's tons of help of AI, but there's no more. I don't think there's we are past the age of being able to analyze our way through things. It's all engineering, really, fundamentally. And last but not least, everyone, there's another joke that I make, but, especially for technical leads and senior and staff engineers, it needs to be the situation that it's not going to happen. Let's say, I wake them up at 3 a.m. in the middle of the night and it's like, hey, what is the threat model you're working on? And that needs to produce a meaningful, credible answer. I think it is pretty generic. That one doesn't have to do with age of AI, but the thing is just very, very important that we work with that framework kind of in mind.
We'll take it. Slava, thank you so much for your time. It was awesome hearing your perspective and learning about your story and what you're focused on, what you're working on. Really, really appreciate you coming by.
My pleasure being here. Thanks for inviting me. And best of luck, everyone.
And for more episodes and blogs and everything like that, you can go to detectionatscale.com, and new episodes every few weeks. All right. Thank you all. See ya.